Okay guys, so today I'm gonna tell you how to do inverse kinematics in Unity. It is so easy to do inverse kinematic in Blender, but you cannot export that inverse kinematic model to Unity. I don't know why. So I made an easy tutorial for you guys. The first thing you need to do is to create a model like this. I've created it like a spider leg. It is this part of the and this part is attached to the body of spider, and this is, you can call, a foot of a spider. So how you can create this model, I'm gonna tell you in a second. So the first thing you need to do is to create one sphere and a cylinder with that sphere. I'm calling this sphere a bone, and this cylinder is a bone length only, the distance between two cylinders. And you have to create it, you have to duplicate it and position it here, and duplicate it and position it, and you have to duplicate it 4 times. So you would get this model. You just need to remove the cylinder from the last bone or the last sphere, like this. Like this bone have no child, it doesn't have any cylinder as a child. This cylinder is a child of this bone. So here is our model is done. Name the script fast IK fabric and attach it to the foot bone, like the last bone, the bone number 3, like I have attached it. So you need to start working on a script. I've already coded it, but I'm gonna explain it to you. First you need to create some variables. Okay, just focus on this highlighted part, these variables. The target is just this target. The target is just this target, which our foot will follow. As the target move around, the foot or the end of the bones gonna move around. After that we got the bones. Let's open the presentation. These are the bones, these spheres, which are stored in the transform array, and it will be 4 of them. And we also got 4 positions, which are just the position of these transform or the spheres or the bones, which are stored in the vector 3 array, like this. The bones are the transform array, and the position are just the position of these transform, which are stored in vector 3 array. The bone length, as I say, the bone length is the distance between two spheres or the two bones. It's just a bone length. And we have another variable which is called complete length. When we the distance between the first bone and the last bone is called the complete length. So let's go to the function. I've explained you all of these variables. The chain length is just the length of the is the number of bone lengths, which I'm giving it as 3 here, which are the 1, 2, 3 bone lengths. It is called the chain length. So you got all the variables. Now time to move to functions. We are calling the awake function, in which we called the init function. What init function is doing, it is initializing the variables, all the variables. The bones array, as I say, chain length plus 1, chain length is 3, 1, 2, 3, and chain length plus 1 are the number of bones, 1, 2, 3, 4. So it is 4 indexed array, 0, 1, 2, 3, and the position are also there will be 4 positions, 0, 1, 2, 3, the position of the bones. And the bone length will be equal to the chain length, which would be 3, like this, 1, 2, 3 bone lengths. And complete length, for now we are going to initialize it with 0. So I explained you all the initializing of variables. Now move on to this part of the function. First we're gonna create a variable called current. I've write it CURR as a current, and we're gonna store a transform in it. Like if I've attached the script on this particular sphere, So it is gonna store this transform in the current variable. And this for loop, all this for loop is doing is it is calculating the distance between two spheres or two bones and placing it in the bones length array. Okay, placing it in bone length array, and it is also calculating the distance for the complete length, like adding all the length to the complete length in the end. So I'm gonna start explaining it little more. First we initialize the bones I, mean the bone on the index 3 as a current or the transform. In this line we are getting the distance between these two bones and storing it in the bone length index number 3, and we are also updating the complete length variable. It was first initialized as 0, but now it have the bone length, it have the length of this from here sphere, from here sphere. And after that it will update the current variable which we set to the transform outside the loop. Now it is updating the current variable as current.parent. What is the current.parent? This one would be the current of parent, so it will be the new current, and the bones I will be this one, and the current variable would be this one, and the bone length would be this one. So by this it is getting the length between these two spheres. After that it is adding it in complete length variable, which now contain the distance between this sphere plus the distance between this sphere, and this loop will gonna repeat once more, and it will find out the distance between these two bones, and also gonna add it in the complete length variable. Now the complete length variable contain the distance between first bone and the last bone, and also this array, bone length array, contain the distance, the separate distances of this bone and this, between this bone, between these two bone, and between these two bone, and between these two bone. Okay, moving on to next function. In the late update function we call the resolve ik function, which start from the two ifs condition. If target is null, if we don't have any target, like if we don't have any target set, then it will gonna return this is our target, which is this one, this sphere. And if the bone length is not equal to the chain length, which I already said you, these two variables are same, the bone length and the chain length is same. If they are not equal for some reason, then it is gonna call the init function again. And after that we got a for loop which is populating the positions array by getting the positions of all the bones and storing them in positions array. And this part is a little bit complicated, but all it's doing is just when we move target from one point to another point, is getting the positions like this position, this position, this position, and this position for placing these bones on this position. And in this last part it is placing this bone on this position, this bone on this position, this bone on this position. So this part is just calculating the position of the new location for the bones, and this part is placing those bones on the positions. This for loop is running to the length of the position array, and it is placing the new position which we got from here. It is placing these positions into bones dot position, bones index number dot position, which is gonna shift all the bones to new positions which we acquired from here. That's all guys, it was a code. Now for a little demonstration, just hit a play button. As you can see, if I move my target up and down, all the bones are following and repositioning themselves in a correct positions. But you're gonna ask, why are these not why are these cylinders are not right? They should be like this, but they are not moving. This is because I'm not setting a rotation of this sphere right now, and this is for the next part of the video. And in this tutorial I'm just positioning the spheres on their new positions. So that's all for now. Thank you for watching, and don't forget to subscribe for the next part.